Hello everyone, welcome back to Cambridge Guru once again. As you know that we are doing complex number, and last video was about complex exponents and Euler's equation, in which any complex number can be written in magnitude and argument form or the polar form. That polar form can be written in exponent form with e raised to power I theta, right? This we did in the previous video. So in this video, we will solve a couple of questions based on that concept. So first one is that it is given that 1 plus 3i w is equal to 2 plus 4i. There is a complex number w which is given in this form. Showing all necessary working, we have to prove that the exact value of w square modulus is 2. Means we need to find out first w square, then we need to find out its magnitude, right? So its exact value is 2, and hence we need to find out the argument of w square correct to 3 significant figures, right? So it is not new to you, I think, right? We just have to form the complex number w0 and then find out its magnitude. So first let us form this w as a complex number, which is given like this, that this is 2 plus 4i, and I can bring this 1 plus 3i in the denominator of RHS. So it is 1 plus 3i, right? Multiplying with its conjugate, it is 1 minus 3i, 1 minus 3i, right? So this will be 2 minus 6i plus 4i, and this will be minus 12i square, right? Divided by, this will be a square plus b square, because I square will be minus 1, that will make minus b square as plus b square. So I'm writing this as just 10. So your numerator will become 2, this will be plus 12, which is 14, minus 2i divided by 10. I can take out 2 as a common factor in the numerator and denominator. So this w can be written as 7 minus I divided by 5. Okay. Now I need to form w square. So let us square this. That will be 7 minus I whole square, right, divided by 5 square, which is just 25. So 7 square means a minus b square we need to find out. So it is 49 square plus I square minus 14i divided by 25. I square is minus 1. So this is 48 minus 14y divided by 25. So this is your w square. And then we need to find out its magnitude. So how we can find out it? Just by squaring the real and imaginary part. So mod of w square will be 48 divided by 25 whole square plus 14 by 25 whole square, and after that we need to take the square root of this. So 48 square is 2304. So this is 2304 plus 14 square is 196 divided by 25 square. I am writing as a separate entity. So in the denominator it is just 25, because I can take out this 25 as a common factor at this place only. So we need not have to square 25 in the magnitude, right? So it is just 25 in the denominator. So your numerator will become 2500 square root divided by 25. And what is the square root of 2500? It is just 50. So 50 divided by 25 is 2, right? So hence w square magnitude is 2. Okay. Now next is we need to find out the argument of this. So it is very simple. You can use your calculator. I am not here giving the value in significant figures, because answer will be coming out in this decimal, right? So I'm just saying that argument of w square, what you need to do is this is our w square. So I need to write tan inverse of 14 by 25 divided by 48 by 25, which is nothing but tan inverse 14 by 48 with a negative sign, right? I'm saying this, this is basically negative. This is the principal value without, negative sign, right? It's in the original complex number, we have 48 minus 14y. So minus in the sense that basically imaginary portion it is below the x-axis, right? And real part is positive, imaginary part is negative. That means it is in the fourth quadrant, right? So we will write the answer in the negative number, negative angle, right? So this is just the principal value. So if you need to find out this, I'm finding out 14 divided by 48, it is 16.26, right? And to three significant figure, I can write this as 16.3, okay? So minus of, or just write this as 16.3. That means argument of W is basically with a negative sign, right? Minus 16.3, that is in the radians, okay? So the second part says that on a single argand diagram, we have to sketch the loci of mod z equal to 5 and mod of z minus 5 equal to mod z. So these are the two different loci for two different set of points of complex numbers, and hence we need to determine the complex number that are represented by the points which are common to both these loci, giving each answer in the form of r e raised to power I theta, right? So let us first sketch these on a argand diagram, okay? So let me take another page. So we have two set of points or two loci. One locus is mod z is equal to 5, and second is mod of z minus 5 is equal to mod z, okay? So please do not get confused that here it is written mod z minus 5 is equal to mod z and value of mod z is 5. No, consider these as a different equations, right? Just like we say x plus y is equal to 4 and x plus 3y is equal to 7, right? Both the lines are represented, both the equations are representing two different types of lines, okay? I'm not here to find out the point of intersection, right? Basically we need to find out, but as a complex number we need to find out the intersection, right? So let us sketch these two graphs or loci. This is your imaginary axis, this is your real axis, and let us sketch this mod z equal to 5. It represents a circle, okay, with a radius 5. So let us sketch a circle with radius 5, something like that, okay? This point is minus 5, this point is plus 5. Then we have second equation, which is mod of z minus 5 is equal to mod z. So as you know that represents a perpendicular bisector, right? So locus of a point z, which is whose distance from the point 5 comma 0. This represents distance of z from 5 is equal to distance of the z from origin, because it is written as mod of z minus 0, right? So this point z is moving in the argand diagram in such a way that there are 2 points, one is origin, one is 5. So its distance always remains constant from these two fixed points, and this we have already done. This represents the equation of a perpendicular bisector, right? If it is a bisector, so this bisector will pass through the midpoint of these 2 points, obviously, right? So we have to sketch a bisector like this, which will pass through the midpoint of 0 and 2.5, 0 and 5, which is 2.5, okay? So let me draw that. So this will be your perpendicular bisector or the second loci, okay? All the points of z will lie on this green straight line, perpendicular bisector of 0 and 5. This is your origin, and this point is 2.5, okay? This is 2.5, okay? And this distance is 5. This distance is 5. Why? Because this is the radius of the circle, mod z equal to 5. Now let us read the questions once again. It says that this we have sketched. Hence, determine the complex numbers represented by points which are common to both loci. So, what are the points which are common to circle and the perpendicular bisector, right? So, these are the points, means this is point P, which is common to the circle and this perpendicular bisector, and second point will be the conjugate of this point, right? Because the graph is symmetrical. Why it is symmetrical? Because we have a perpendicular bisector with a straight line passing through the, or which is parallel to the y-axis, and there is a circle, right? So it is just the reflection of point P. So let us say this point is P dash. Okay. All right. So let us find out this angle theta. So basically this complex number we have to find out which are lying on the circle as well as on this perpendicular bisector, right? So we have a complex number whose magnitude is 5 in this case, right? Magnitude, this distance is representing, is actually 5, so we have the magnitude of that complex number as 5, right? And then since we need to find write the answer in r e raised to power I theta form, so r we have find out, which is 5. So one thing is theta we need to find out, right? So how to find out this theta? It is very easy, that in this triangle OP, let us say this point is M. So in triangle OPM, in triangle OPM, if I apply cos theta, okay, cos theta is base over hypotenuse. So base is 2.5 and hypotenuse is 5. So in this case, theta comes out to be cos inverse half. So cos inverse half means angle is 60 degrees, or in radians we need to write this is pi by 3, right? So now we are in a position to write our complex number in exponent form. This is the, we do not need to find out this Pm. This is the beauty of this complex number which is written in exponent form, right? We need to find out, we need not have to find out this Pm, right? Otherwise this will come out to be in decimal form, right? Applying the Pythagoras theorem, then this will be 5 square minus 2.5 square will be something, okay, that does not come out to be 5, or not 5, exact value won't come out, okay. So but we know we are in a position to write this complex number without finding out the imaginary portion, right? So we have a magnitude 5, so this z complex number represented by P can be written as 5 e raised to power I times pi by 3, because we need to find out the, we need to write the answer in r e raised to power I theta form, okay. And similarly z of P dash, as this will be the just the mirror image or the conjugate of this, so whatever is the angle here, the angle made by P will be just the negative of this theta, because we are measuring angle clockwise. So zp dash will be, magnitude will remain same, it will be just minus of I pi by 3, okay. So these are our two complex number which are common to both the loci. All right, let us do one more question. It says that a complex number w and z are defined by 5 plus 3i and 4 plus I. We have to express iw by z in the form of x plus iy, showing all your working and giving the exact values of x and y, right? So it is again very simple. Iw you can write down by multiplying the complex number w with I, which is 3i square is minus 3 plus I times 5, or 5i, right? And dividing by w means iw by z means minus 3 plus I5 divided by 4 plus I, okay. Multiplying this with the conjugate of the denominator, which is 4 minus I, okay. So minus 3 into 4 is minus 12, minus 3 minus I is plus 3i, then this will be plus 20i, and then minus 5i square, which is plus 5, divided by 16 plus 1 will be 17, okay. So iw over z is minus 12 plus 5 is minus 7 over 17 plus I times 23, over 17, right? So here the value of x is minus 7 by 17 and y is 23 over 17. Okay, very simple. This is your first part. Second part is that find wz, and hence by considering the arguments show that tan inverse 3 by 5 plus tan inverse 1 by 4 is pi by 4. Although we have an identity in inverse trigonometric functions that tan inverse x plus tan inverse y is tan inverse x minus y over 1 plus xy. But since inverse trigonometric functions is not the part of the syllabus of 9709, so we cannot apply the identity, right? So how, and it says that hence by considering arguments, so we need to apply the law of arguments, that two complex numbers are in multiplication, so arguments get added, right? So first we need to write down this w and z in, let us write down in e raised to power I theta form. Okay, so you have in the second part w was 5 plus 3i, right, and z was 4 plus I, right? So here I can write down mod of w because I need to write this in r e raised to power I theta form. I think we need not have to write this in, means we need not have to find out the magnitude of this because we need to focus on the argument only, right? So as two complex numbers are in multiplication, so let us just consider the arguments of these two. Okay, so combating this, I am writing that argument of w and z will be equal to argument of w plus argument of z, right? This we already learned. So argument of w is tan inverse 3 by 5 and argument of z will be tan inverse 1 by 4, right? So how we can prove that this is equal to pi by 4? So let us multiply these two, w and z, okay, and let us find out what complex number we get if we multiply w and z. So w is 5 plus 3i and z is 4 plus I. So 5 into 4 is 20. 5 into is 5i. So it is 5i plus 12i, and this is minus 3. Okay, so you will get real portion as 17 and imaginary portion is also 17. So here if I say that argument of wz will be tan inverse of 17 over 17, which is tan inverse 1, which is pi by 4. Okay, so first we have considered that argument of wz using the identity that argument of wz is argument of w plus argument of z, and by multiplying wz we get another complex number which is 17 plus 17i. So its argument also matches with the argument of, it should match with the argument of wz, right? So these two equations should match. This is equation 1, this is equation 2. So hence we can say that tan inverse 3 by 5 plus tan inverse 1 by 4 is equal to pi by 4. Okay, if the question is asking that represent this wz or iw over z in the form of r e raised to power I theta, so in that case you have, again you need to find out the magnitude and the argument of these two. Okay, so that is all as far as questions based on polar form or the question based on exponent form are concerned. In the next video we will talk about the complex roots of the equation, right? Till then, take care, bye.